Work by conservative forces. So the first example of this is work done against gravity. So in order to lift a 10 kilogram object 7 meters high, all right, work equals a change in energy. So in this case, it's going to be the addition of the potential energy due to gravity. So mgh, which also you could write it as the force times the distance you acted against that force. So in this case, they're in the same direction, so I don't have to worry about that angle. So it's just Fg times h. So either way, it's 10 for the mass, 10 for the acceleration due to gravity. We're going to round it, all right? And then times 7 meters high. So I get a total of 700 joules of work. So does my path matter? Does it take the same amount of work if I walk 10 steps sideways first? Well, I've moved, so of course I've done more work. But this is one of those cases where the English language daily use of the word work doesn't match with the equation, okay? Because we're only talking about the work done against gravity, all right, that was only in the vertical direction. So I'm only concerned about my displacement in the vertical direction. So again, this is only looking at the component of motion parallel to the force. Why? Well, it's because gravity is a conservative force. What that means is the work I put into the system, I can get back without it costing me anything. So if I lift that 10 kilogram object up and then I drop it, conservation of energy applies. There's no loss of energy to the object Earth system. All that potential energy that's stored in the field gets converted to kinetic energy with no loss. So some other conservative forces that we will see in this course: spring force and electric force. So this brings us to something called isolines. So iso means the same, and well, you know what a line is. So an isoline, all right, is a line where the potential energy is the same at all points on that line. So that means that moving from one location to another on the same isoline costs 0 work. So one example, all right, of an isoline is if you've ever seen a topographical map, and this is of an area just outside Lake Tahoe. So you can see that there are kind of these contour lines, and this is what's called a topographical map. So each contour line represents locations that are at the same height. So in order for me to go from, say, like Lake Tahoe to any point on one of those same contour lines, I'm now at the same elevation, so I now have the same potential energy due to gravity. It also means if I walk along one of those lines, I have done no work against gravity because my height has not changed. So another example is a nautical chart. Now this one doesn't draw every single isoline, but they will draw some major demarcations in depth of water. Okay, so again, these are all above the center of the Earth, so they are all at different potential energies. Okay. So if I drop something in the water and it's denser than the water, it will still sink. So I've put a little arrow here, and you can kind of see where there's a line where it changes from a darker blue to a lighter blue. So that's an example of an isoline on a nautical chart. So this happens to be Hampton Roads, and that's Norfolk Naval Station there with all that purple to the right of the arrow. That's where I was stationed when I was in the Navy.